So, welcome to my talk, Synthetic Monitoring. Before we get into, let's recap in a few slides what this bulky word synthetic monitoring means. Database monitoring means we are monitoring databases. Network monitoring, we are monitoring network devices. Synthetic monitoring means the way we are monitoring, which is synthetically. This is namely to mimic and monitor the interactions of users with a target system, with an application. And this gives us insights about availability, performance, and functionality. Why is this important? In Checkmk, you can monitor a lot of different things. But this is always from the perspective of the monitoring system and not of your end users. The one and only thing what really matters for your end users is that they can use these applications. When Checkmk reports you a broken cluster node, for example, your users won't see any impact. But on the other hand, there's always the risk of the reverse case. Users report problems in the application, but your monitoring is green. You can have the greenest monitoring ever, but you're still and always measured by the quality of applications you are delivering. And this is why we need to automate these user actions. And there are a lot of tools for this. And the question is, which one is the right? A few thoughts about this. In the first row, all the tools should drop out which are bound to a certain technology. For example, pure web testing tools, because you never should come into the situation that if you need to use some other testing technology, that you need to introduce another testing tool. A testing tool should be extensible. It should have a clear programming API, which should allow to program extensions and so on. A big user base is always good. And lastly, the tool should be both flexible and easy to maintain. And Robotmk is a tool which really fulfills all these criteria. Robotmk is called a generic test automation framework, which means it's responsible for the test structure, the syntax, error handling, reporting, and so on. But all the technology is outsourced into so-called libraries. Robotmk and the libraries are completely written in Python and open source. And there are a lot of libraries. Libraries for web testing like Selenium, Playwright, UI testing, image comparison, network protocols, Kubernetes, AWS, and so on. And one of the key features is the keyword-driven approach in Robotmk, which means you are writing your test using keywords which, under the hood, execute Python source code. So as a test author, you normally don't get in touch with any Python code. This is how a typical Robotmk file looks like. It's a simple text format. In yellow, you can see the keywords, and right of that, arguments. So you call them like functions. And by the way, happy birthday. Yesterday, 15 years ago, Pekka Klerk released his first version of Robotmk. It was the result of his master thesis while he was working at Nokia Siemens Networks. So a great time, 15 years. And you know, Robotmk is a really outstanding kind of open source tool because it's owned. It's owned by a foundation. Over 50 companies are part of it and make it possible with their membership fee so that something really special can happen. The foundation can pay a handful of full-time developers, for example, Pekka Klerk, the founder, to work on an open source project. And this ensures that Robotmk never can be taken over by a company. So if your company is using Robotmk already, just think about a membership, just ask me. Up to here we have defined how we test, which is synthetically, the testing tool, Robotmk. And a test always gives me a result whenever I execute it. Monitoring means to execute tests on a regular basis and to compare the results with an expected state, to record the metrics, get notified, and you all know it, that's the business of Checkmk. In 2020, I was looking for an integration of Robot Framework into Checkmk, and I didn't find any useful, and so I wrote Robotmk. In the course of time, Robotmk did not only become popular within the Checkmk community, but interestingly also in the Robot Framework community, which discovered the topic of monitoring. So this is an example of Robotmk executing a playwright-based Robot Framework test at the Carl Zeiss AG. Thanks to Tobias Raab for the permission to show this. It's testing a web shop called VisuStore where opticians can order individual lenses for their glasses. It goes through all the steps of the ordering process, and the result are a bunch of services in Checkmk which represent the different test steps. And they have a nice Nagios dashboard where they can see the status of this execution. You know, developing Robotmk as a single developer was not always that easy. Besides my free invested time, I could only invest the time which customers paid me for. And this inevitably led to rather small and specific changes. You don't make the big moves with that. Since last fall, I'm lucky enough to work part-time as a product manager for synthetic monitoring at Checkmk. And together with the developers, we are not only able to improve the overall code quality of Robotmk, a deeper integration into Checkmk is only possible with that. So let's go into what we are working on now. Question to you, who is already using Robotmk? Oh, that's great. You will probably agree that writing the test is not your only task. You have to set up the test nodes and maintain them. You have to set the test execution interval properly, and you have to create views and dashboards and reports. And this is a never-ending, a repeating task which sometimes gets underestimated, you will agree. Most of the efforts take place in step 2 and 3, and manual effort leads to errors. And this is why we are focusing on these 2 steps in milestone 1 and 2 to introduce automation into these steps. On the next slides, I will show you in both cases where we are today, our considerations, and the solution. And before we dive into, if you think, hey, that's what he told us last year again, that's not really true, because last year I presented ideas and concepts, and in winter I started to work part-time for Checkmk. And what you see now is what I have prototyped within the last about 6 months. And in the next few weeks, a team of 3 developers, Jörg, Solomon, and Luca, will start in the team Robot to work with me on that. So let's have a look at test scheduling. Today, version 1 of Robotmk executes all the suites in one series on a host. So the total runtime must always be lower than the execution interval. And the more suites you add, the longer the total runtime gets. And sooner or later, this overlaps the execution interval. You probably know this. You have 2 options now. You can install a new test machine, which doesn't scale very well, or you are setting the execution interval higher. But in this case, you are losing information resolution. So if you set this interval too high, you're probably wasting resources. And with each test you're adding, you have to constantly monitor and readjust this execution interval just to find a nice compromise between idle time and overlap. So a lot of pitfalls to step into. And a question I always got in the past was, if starting a series of suites is a problem, why can't we execute the suites individually as asynchronous plugins? There are a few reasons not to do this. How should the plugin know which suite to start? I didn't want to use MRPE for that. The Checkmk agent cannot start a plugin multiple times. What should be needed if I need individual intervals? I would have to duplicate the same plugin multiple times, but this is ugly. By default, asynchronous plugins can be killed by the Checkmk agent if they are running too long and running into timeout. I would say in 100% of the cases in Robotmk, robot framework tests are the root cause of this. And if the Checkmk agent kills Robotmk, I get no result at all. So it should be in the responsibility of Robotmk to terminate overlong running robot framework tests to return something to the Checkmk server. So at the bottom line, it was clear to have a separate Robotmk scheduler which runs side by side by the Checkmk agent. And let me now explain how this will work on Windows. In version 1 of Robotmk, the bakery deployed the Robotmk Python plugin. In version 2, this will be a so-called controller plugin. This is written in a system scripting language like PowerShell on Windows or Shell on Linux. This example is for Windows. This controller has two tasks. It has to start the scheduler, and it has to produce agent output. First, the scheduler. On a fresh virgin Windows machine, the controller will search for the Robotmk Windows service, won't find it, will install it, and start it. That's all the controller has to do, because it has to return immediately. It's a normal check plugin. The Windows service, in turn, will start Robotmk in scheduler mode. And this, in turn, so this is the Python part of Robotmk, this, in turn, will start itself in suite run mode for the individual suites in individual intervals. And in each of these sub-processes, Robot Framework will run and produce the result files at a defined location. The second task of the controller is to produce the agent output. In this mode, it will search for the most recent result files and produce agent output. And inside of this output, there are some Robotmk metadata, start, stop time, and so on, and also the XML result file, which Robot Framework has produced. This file contains start and stop times of every keyword executed. It can also contain base64 encoded screenshots of error situations. It can also contain screen recordings, so animated GIF videos of an error situation. In Robotmk version 1, I transferred the XML and the HTML log file, but the HTML log file is nothing more than a human-readable version of the XML file. And for that reason, we only will transfer the XML file and the HTML file, which will be generated on the Checkmk server. And this gives us a lot of nice opportunities. We can influence the look and feel of the log file. We can also enhance it with further information, like graphs, for example. And yeah, it saves bandwidth. That's it. You see that the long and independently running tasks in the green box are completely decoupled from the Checkmk agent, while the output mode of Robotmk is executed every minute by the controller to produce the agent output. The scheduler is only started once and running forever. And this is done, so the Windows service is only started on demand by the controller. It doesn't start automatically. And in this way, we can ensure that the scheduler only starts when the agent starts. And on the other hand, by the, and the controller at each execution also updates a so-called daemon switch file, which is monitored by the scheduler. And as soon as we shut down the Checkmk agent, the scheduler will see the aged out daemon switch file and also terminate. In this way, we can ensure that the scheduler terminates when we shut down the agent. Precondition here is always to have Python installed and the dependencies for Robotmk, the Python dependencies. And this leads us to the second critical point we looked at. These are the efforts which you have to maintain a test node. Maintaining Python packages can be painful. And if you are using dedicated machines for Robotmk, at least I hope so, you have, I think for sure, have seen these problems. Let's assume you have a test machine where you want to run a robot framework test. It has dependencies for packages A and B. You install these packages, the test can run. You want to run another test on the machine. It has another dependency to package C. No problem. You can install it and both suites can run. And now comes test 3. Test 3 has a dependency of package B to another version. And now we have a problem. We have only one place to install packages, but we have conflicting requirements. And yeah, how to deal with that? Wouldn't it be better? No, one sentence more. You have probably seen this as it works on my machine problem, because this can also hurt you if this is not your test machine, but your development machine, where you have to develop and maintain all the tests which should run somewhere else. So how can we deal with that? Wouldn't it be better if we could rely on the fact that we get dedicated Python environments for each test so that the test can run anywhere? If you now think of virtual env, that was also my first thought, but it doesn't work for several reasons. The requirements.txt file, which you normally would use for that, only specifies the main package dependencies. For example, for A, B, and C. But if package B has a subdependency to a package which has no specific version number, you probably get tomorrow another environment created than today. So not very clever. Tools like pipenv can handle this. They are using log files, but they are limited to Python. I already mentioned the Playwright library, and I highly, highly recommend to use Playwright instead of Selenium library, because it saves you a lot of trouble, but it has a dependency on Node.js. Can't be handled by pipenv. And a part of the way of how we build the environment, the question is, how can we automate the whole thing? We cannot assume that you out there will find a solution on your own. In the end, we are the company who wants to produce an enterprise product, right? And if we implement something for you, we cannot choose the automation tool for you. We cannot choose Ansible for that if you're using Puppet or Chef or something else. So the solution is here to set up the setup of the test nodes must be completely transparent for the user. And this is where a nice tool called RCC can help us. It's written by a company called Robotmk, and they are offering their customers a cloud orchestration platform where customers can run their automations. Python code, robot framework code, whatever. And they had exactly the same challenge. How can we ensure that the automations which users are programming on Windows, Linux, Mac can run in our infrastructure? And so they developed RCC, which uses a special YAML file which defines from where to download packages, which packages to install, in which version, and additional commands in the end. You see in this example the RCC post-install command, which is used to initialize the npm packages for the Playwright library. So in this way, you can create completely ready-made environments which can be used to test. So with that information, RCC creates these environments, and this is kind of comparable to Docker files. If you know how Docker files work, they are specifying software environments where some code can run. And with RCC, your automation code, your robot framework tests become really transportable, even if they are depending on, for example, Node.js. RCC will be integrated in the commercial version of Robotmk. And to make it more clear to you what kind of game changer RCC really is for Robotmk, I show the architecture diagram again. When Robotmk finds a robot framework suite to execute, it will check for this YAML file and create the specific RCC environments for that. But that's not all. Due to the fact that Robotmk is in version 2, not anymore a simple Python script, but a Python package which you can install, the controller can also create such an environment for Robotmk itself. And this environment can be used by both the scheduler mode and the output mode. So in summary, we can say that everything in white is what we have already anyway on the client, and everything in green is what the controller is able to kind of bootstrap with the help of RCC. RCC is really tailor-made for this task, platform independent, very efficient with disk space, has a housekeeping mechanism to delete old environments, and has a brand new mode called RCC Remote, where it's possible to install these environments in a kind of offline mode. So this is how I have developed this prototype for Windows in the past months for version 2.3. The parallel executioner will be part of the open source project, and RCC in a specific synthetic monitoring license. So now we have seen what was, what is, and what I and the team Robot are working on in the next months. Lastly, I would like to give a little preview of what will be. What are the further milestones? First, test creation. Robot Framework should be usable by everyone, but not everybody is familiar with Visual Studio Code, for example. We want to provide you a solution which makes it more easier to write Robot Framework tests with a kind of low-code solution. There's a nice tool called Automation Studio, also written by RoboCorp, which will be integrated. There will be also a kind of no-code mode, where it's possible to select small and specific ready-made robots selectable from a kind of catalog within Checkmk to execute some small tasks on remote hosts. The second topic we are focusing on in future is the presentation of data in Checkmk. Similar to Kubernetes, we want to provide ready-made dashboards which should really assist you to quickly find relationships between problems in your infrastructure and the end user experience. We really want to dovetail Robotmk with Checkmk. So with that, I'm almost at the end of my presentation, and I want to close with a few questions. When do you think is a car ready to drive? Would you think it's enough to know the metrics from the onboard computer? Or if an emergency doctor finds an injured person, would he first measure temperature or blood pressure or something? Or would he try to talk to the person? Or would you say it's enough to test a pilot's knowledge about his ability to fly a plane? Or would you also send him in a simulator? I'm asking these questions because our real life is full of examples of complex and very important systems where it's simply not enough to simply check individual states of these systems, but to test their functional interrelationships using predefined sequences. And unlike in real life, we in IT, we can enormous benefit from automation using a tool like Robot Framework. And with the help of Robotmk, we can bring this technology into Checkmk to build synthetic monitoring into. And with that tool, we want to provide you the ability to keep your applications available, performant, and functional. Thank you very much. Any questions?
Test, hello, yes. So, from Philip, will there be documentation on how to set up Robotmk without using the bakery?
Without using the bakery? We can try. It should be possible, yes.
So maybe explain what the bakery does in this context.
Yeah, the bakery, main part of the bakery is to generate the YAML file, which is read by Robotmk on the client, where all the suites are defined, the execution intervals, parameters for Robot Framework also, and stuff like that. And currently the format isn't well documented. So if we document it and you know how to generate it, you could probably also generate this with some automation tool like Ansible. Yes.
Then, if you're now a user of the previous Robotmk plugin, yeah, and now, I mean, you're doing fundamental changes to how Robotmk works. Mm-hmm. What happens to, like, what is the implication for existing users of Robotmk? Will there be any changes for them? Will you build a new thing? How is the migration path?
Okay, I would say don't worry, because most of the effort you have put into writing the tests. And what you would have to change is the rules, because Robotmk version 2 will be a completely new version, and you will have to uninstall the MKP, and it will be available integrated into Checkmk in version 2.3. So there will be new rules, new data structure behind. So this is what changes on the Checkmk server side, but all your automations you have written can be used in the same way.
Okay. Some licensing questions, or how we will sell it, yeah. Or what basically, maybe you can explain again, what will be part of the community edition of Robotmk, and what will be part, and how we think about what becomes part of the enterprise piece of Robotmk.
Yeah. Simply put, everything you can do today with Robotmk will be possible with the version 2 of Robotmk. In addition, the parallel execution. The integration of RCC is meant to help you in big environments where it's too much effort to maintain all the test nodes, and this will be part of the commercial version with a special license. Yeah.
And we have not actually made up our mind how we actually sell that or where we sell it, if this is part of the cloud edition, of the enterprise edition. Actually, we don't know yet the answer. We haven't thought about it yet, because our priority was to actually build this, to really work on the code, to really work on the concepts, know, can we solve all these challenges? Because they were not simple challenges, they were quite challenging. And that was our focus, so we actually haven't thought about how we'll monetize that. But yeah, you'll think about it in the next months. Let me see. I think the question from Christian you already answered, but RCC requires typically an internet connection to get the packages. Yeah? But what if you don't have an internet connection, if you have an offline environment?
Yeah. So I already mentioned this RCC remote mode, which is quite new. And before that, it was already possible if during the environment creation time, there's a special zip file which can be created on a similar system, which exports all the downloaded packages. If this zip file is found, it will be imported so that a completely offline installation is possible. And this RCC remote mode will enable you to host a specific instance of RCC, providing these zip files for RCC clients which are requesting these files. And this will be with a secured connection. So Robocorp has put a lot of effort into this technology, and we can use this in Robotmk too.
Then we have from Jan Philipp a question. You showed we basically built this piece for Windows now. Are there any plans to also do that for Linux?
Yes, of course. But I mainly focused on Windows because from my experience, 95% of all the projects start with Windows at least. And I want to have a first version which runs on the system which most of users will use. And the integration of Linux will be probably part of the 2.3 release if there is time. And if not, it will be one of the first things we will implement after that.
Then we have from Gerd a question regarding the parallel execution. Yeah? And I think we probably have to clarify a little bit how the parallel execution works or where it works, because the question is, does it have a negative performance impact if you make the parallel execution of the checks? But it's not checks which are being done in parallel, I guess, yeah?
Yeah, good question. So you always have to ensure that the system you are running these tests on has enough resources. And the question is especially good because if the system is under high load and you're running end-to-end test, and perhaps you have an SLA contract with customers, you're getting bad performance data. So it will be needed to implement some mechanism into Robotmk to monitor the local resources, and it's always better to skip an end-to-end test before you run it under bad conditions. So this will be the limitation where Robotmk will refuse to start an end-to-end test, which probably will influence your availability report or KPIs.
Then from Christian again, can RCC run on Docker?
RCC runs on Docker, yeah. This is exactly what Robocorp does. If you're interested, robocorp.com, it's a very clever made orchestration platform for automation, for running code in the cloud. It's a really cool project. This is based on RCC. Yeah.
Okay. Any further questions? And thank you very much, Simon.
Thank you.